right, in this lecture, we're going to be talking about how to use this thing to develop a linear regression model. So suppose I measured two numerical variables simultaneously. The first numerical variable is going to represent the number of hours of sleep. And the second numerical variable that we're going to measure is GPA. And we're going to measure both of these two numerical variables simultaneously for our sample. So one guy had 6 hours of sleep and they had a GPA of 3. One person typically has, let's say, 8 hours of sleep. They have a GPA of 4. We have 7 and 3. Let's do 2 and 1. 3 and 1. 4 and 2. 5 and 3. And we'll stop there. And so the question is, can we develop a linear model to represent the relationship between the number of hours that you sleep and your corresponding GPA? Now, if we notice that this model is definitely not perfectly linear, and if we take a look at this, for example, this shows us that essentially in that interval, the slope was, or at least the average rate of change was 0, but in some cases, the slope is like 1. So this is not a perfect linear relationship if we were to draw this on a scatter plot. Now, what do we do with this guy? Well, pretty much every problem is going to be the same in terms of what we do. We're always going to hit the stat button, and we are going to hit enter. And now we're going to be brought to our lists. This is where we can input our data. Now, you can use the left, up, right, and down arrow to maneuver around your lists, but I want you to go to list 1, and there should be these dotted lines, and I want you to hover the mouse over those dotted lines. Mouse. It's probably not really a mouse. If you have any numbers already in L1, just delete all of those numbers, and you're going to plug in this case, this variable, the number of hours you sleep. Do it in the order that I have here. 6, 8, enter, 7, enter, 2, enter, 3, enter, 4, enter, 5, enter. You do that for all of your of the numbers for the number of hours of sleep. Then we're going to go over to L2, and you're going to also plug in these 7 numbers here in the order that I have shown. So 3, enter, 4, enter, 3, enter, 1, enter, 1, enter, 2, enter, 3, enter. It's really important that you notice that L1 and L2 are the same size. They should have exactly the same size. They should both have 7 numbers total. Now we can quit. We can hit second mode, which is quit. And we go back to our stat menu here. Now, again, there are 3. I'm showing this to you guys, and you can't even see it. My camera can't pick up the pixels on this thing. So there should be 3 menus: edit, calc, and tests. And you should see this at the top. Once you go to calc, now you can do that by hitting the right arrow button. And then number 4, you should see lin reg. So you should be able to see something like 4 lin reg ax plus b. And yes, in this case, a is your slope and b is the y-intercept. And I know that's really annoying considering we did bx plus a the other day. It's just everyone does it differently. Doesn't really matter. So you're going to go over to lin reg, and it's going to ask you what's your x list, what's your y list, and that should be L1 and L2. If those are not L1 or L2, then you can hit second stat, which gives you access to your lists where you can figure out what list you want to put where. So it should be L1 and L2 for your X list and Y list, respectively. You're going to scroll all the way down with the bottom arrow until you hover over calculate. Hit calculate, and you should see something like this. Y equals AX plus B, A equals 0.5, B equals negative 0.07. Here, I'll put in exactly what it says here. Negative 0.0714, and so on. So we have developed our linear relationship. But a really good question is, how good is this linear model? Well, we would need our R squared value. Now, you could calculate the R value, which is the correlation coefficient. I'm more interested in the coefficient of determination. Now, to get there, we are going to hit the vars button. Looks something like this. It should be next to the stat button. And this is where if you ever want to gather any sort of specific variable that has been calculated, this is where you would go. And if you scroll down to statistics, it should be number 5. You're going to see several menus. I think a total of 5 menus. One of them is going to say XY. One of them is going to say sum. One of them is going to say EQ. One of them is going to be test. And then the last one is going to be PTS. We are going to go over to EQ. So we're going to hit the right arrow twice. And then we're going to scroll all the way down. And eventually you will see R squared. You're going to click on R squared. Now, not the capital R squared, but the lowercase r squared in this case. And then we're going to hit enter again. And we're going to hit enter again. And we get an R squared value of 0.9074 and so on. That's a pretty good R squared value. So that just means that our linear model is really good at predicting the coordination between the number of hours slept and your GPA. Again, I like R squared values above 0.95. There's no specific reason, no scientific declaration that 0.95 is magical or anything like that. But R squared 0.95 is something that I typically like. Anyways, that's pretty much it. That's how you do linear regression on your calculator. If you go back to stat though, and you hit calc, you'll notice, by the way, there is a lin reg, a quad reg, a cubic reg, a quart reg, a lin reg again. But that one, it's a plus bx, which is the one that we've been working with. It doesn't really matter. It makes no difference, literally. There's an ln reg, which is a natural log reg, x reg, power reg, logistic, sine reg, and then there's actually a literal manual fit. So yeah, let me go through what those mean. Quad reg is quadratic regression. Cubic reg is cubic regression. Quart reg is quartic regression. LN reg is a natural log regression. Exp reg is exponential regression. Power reg is power regression. And sin reg is sine regression. So the way those work is exactly the same. It's going to ask you the same options and everything. So nothing interesting there. Anyways, that's how you use your calculator to do some regression. Thank you guys so much, and I'll see you in the next lecture.